Hello guys, welcome to this new episode, today number 46. Today we're gonna talk about something slightly different than what we are used to. We are going to talk about neural style transfer. So let's get started. Okay guys, so welcome again. As said during the preview, today we're going to discuss different topic than what we are pretty used to. So you had the chance during our episode in these last months to familiarize with what we do here, and we are of course always talking about machine learning and stuff related to it. It's we see this channel as well as what we do here as a chance to investigate cool stuff about this domain. And today is one occasion in which this tries to is an experiment trying to merge something really cool that can be done with deep learning and video games that are interfaced with our environment that is built for reinforcement learning, but at the same time it gives us the opportunity to handle them in a very peculiar way. And so this was a very good occasion to investigate a little bit and to familiarize with a topic that is it goes under many different names, actually a few different names. One of the very famous is neural style transfer. So we are gonna see what it's all about. Before getting started, let me briefly recap what is happened during the last episodes. So 2 days ago on Tuesday, we had our standard evaluation episode for our AI tournament, and things are starting to get hot in here. As you can see, there were 2 different submissions, and one of them, Alessio was able to reach second place, and Kenshiro in his very first submission was able to reach the top of the leaderboard, as you can see in our page. And a very cool thing happened. The very first run episode with his submission was able to complete the game, if I remember correctly, without losing any single round. And so that is that was very cool, and is very rewarding knowing that people out there in the RL community is they are starting to familiarize with how we handle this stuff. And so they're playing around with our RL environment. You can get access to it very easily through our website, diambra.artificialtwin.com. There is the GitHub icon on the very top bar, and you can just go there and download it and install it right away very easily. And if you need assistance, but also just to interact with the community, you can also join our Discord server. Again, through the website on the top bar, you do have the link in order to join it. The community is growing and is very, very, exciting to be part of it, because we are always sharing cool stuff. We are preparing a lot of news in the coming weeks and months. So make sure, you join the server and stay with us. Yeah, that's all more or less. Just let me remind you that every week there is a weekly deadline on Sunday night for your submissions of this AI tournament. They are usually then evaluated on the following on the next Tuesday, and so we'll see if next Tuesday we are gonna have additional submissions, new submissions, and in the meantime, we are also doing another thing. So if you remember, we trained here 2 agents, one for Dead or Alive and another one for Street Fighter 3. And so we decided a couple of weeks ago to start doing the same stuff on the third game we interfaced. That is Tekken Tag Tournament, a very complex one with tricky parts. And we are training an agent on it. So right now we reached like 10 days 24/7 training. We're about 15 million training steps. We evaluated it after 7.5. It was showing improvements with respect to the very random agent, but still we are not, I believe we never won a single round there. So this week, I don't think we are gonna have the time to evaluate it again, so we are moving it to the next week, and we'll see how it, how it will behave after another 5 days of 24/7 training. Really curious to see if our approach will be able to, solve also that game. That is quite tricky, as you know. We already explained specific things of that game. We'll see how it goes. But okay, that's all for our recap. So let's start with today's topic. And today, together with me, there will be one of our standard, let me say, and guests. And let me welcome again Alessio. Hello, Alessio. Nice to have you here.
Hello, guys.
Oh, great to have you here again.
It's very nice to be here. Thanks for the invite.
Of course, always a pleasure, Alessio. So you are gonna give us a very nice overview of style transfer, neural style transfer, isn't it?
Exactly.
Oh.
Tonight we're gonna talk about style transfer, and I think it's really amazing. It's incredible how this field exploded during the last few years.
Yeah, I totally agree with you. I remember myself, I was starting to approach machine learning in general. I was still waiting to figure out, what was my preferred subfield of machine learning. But I clearly remembered how I got amazed by capabilities that were starting to happen. I believe it was around 2015, 2016, more or less. And there was, a bunch of research guys that were experimenting how to transfer style among between images. And so that and we're gonna see that today. It was very, very inspiring, because I'm really bad at, this is something that I already shared on LinkedIn. I'm really bad at manual arts like painting or drawing. And so being able to code something that is able to do the task for you, well, okay, that gave me this, the feeling that I would have been able to do cool stuff in terms of art, also with my limited talent in that specific domain. So all these
it's the
aspects.
Same for me. It's also the same for me.
So all those aspects were made this computer vision specific application. Very, very attractive, and also in some sense I was really I wanted to learn what was doing the trick internally. And so yeah, I started taking a look at it, and I always thought, oh yeah, that would be great, like how can we use it in order to create new stuff that is also original, as well as on some sense based on these technologies. Like I was wondering about things like applying this approach to produce pictures, or pictures, something like that, to be hanged at the walls inside my home. Yeah. Because that would be great, in terms of creating art that is kind of also generated by AI, let me say. And but also another cool thing that we are gonna see later today is, I wondered, okay, in DIAMBRA we have access to the frames of our video games. So what would it be, like to apply these kind of things on our video games? So I was, really intrigued by this aspect, and so we are gonna test it in a very experimental way later on. But I believe that for now I will give you the floor, Alessio, and for your presentation that is already on the screen. And really, again, let me thank you for preparing these slides, and really, you're looking forward to hear your talk.
It's a pleasure for me. And yeah, you mentioned 2014, 2015, and I must say that 2014 maybe has been a really gold year for deep learning, because there were so many papers. We had adversarial examples, generative adversarial networks, and really a lot of stuff. But it's even more crazy that we had all this breakthrough now, because actually convolutional networks were discovered in the 90s. What made the difference is that in the 2010, we were able to start doing backpropagation more efficiently. Actually, we could have maybe achieved all these results 10 years ago, or even before, if we only had automatic differentiation. And it's crazy how much there is still to discover. Yeah. But this is something I wanted to share with you about how crazy this field is.
Yes, of course, I totally agree with you. And one thing that I really love about this domain is that it's so young in some sense. I mean, discoveries are emerging every day, and so there is also a lot to study, and so trying to advance what we know today. And so this gives me a sense of discovery, and also I also wonder basically every day what is gonna be this field in like 5 years from now. Not 50, okay, 5 years, because it's exploding. And so it's really amazing about this field. This is really amazing.
I think GPUs, graphic cards, and the Python, the automatic differentiation are really made the change here. But anyway, let's start with the first slide, and let's try to understand what is style transfer. So as you said, you were not that good in arts, but neither was I. I wasn't really good, and I always dreamed of being able to paint something like really nice. And what is style transfer? Style transfer is about transferring the style from an image to another image. So here we see Starry Night from Van Gogh applied to Mona Lisa from Leonardo da Vinci. And you see, this is, it's beautiful. It's crazy that a computer is able to do such a thing. And imagine what we could be able to do in the future. But this is not like new research, and we can see it from the next slide. Actually, this kind of research has been studied since the early 2000s. And in the early 2000s, researchers were working on image analogies and quilting. Quilting is about being able to construct larger images from smaller images. And image analogy, we can see it from the figure. We have image A prime, B, and B prime. And imagine I tell you, I want you to find a new image B prime, the one on the right. I want you to find an image B prime that relates to B in the same way as A prime relates to A. So you see here A and A prime. The only difference is a blurring effect. So A prime is blurred with respect to A. And the idea is that the computer should be able to find a new image B prime that relates to B in the same way as A prime relates to A. It's a simple effect. We know how to blur an image, but here the intelligence part is the machine needs to understand what kind of effect to apply in order to obtain an analogy. And people have been studying this for like years, many years. And just recently, neural networks managed to unlock it. Next. Here we have another example of an image, always from analogy. And here, what I want to show is that people at the time were doing research mostly on analogy between an image and textures. So how to apply textures to an image. It's not hard to do. It's simple, but it was like the best we could do at the time. Next. And finally, in 2016, these people, Geddes and other, were able to create this new field called neurostyle transfer. And it's really, really beautiful. If you look at the left image, the 4 images, we have this city that I think it's a city in Germany. And we have other 3 images, which is this city, to which it has been applied different styles. So we have the shipwreck of the Minotaur, that's image B. We have Starry Night by Van Gogh, image C. And then we have the Scream of Munch in image D. And the style of these pictures, of these images, paintings, has been applied to this city in Germany. And we see, we get really nice results. It's not, we don't get sloppy paintings, but it looks cool to me. We really get a mix of the 2 images. And on the right, we have New York by night, and we have London by day. And the bottom image is the net effect. So what happens if we try to mix the 2 images together? And it's really cool. It looks like an alien planet to me.
Yeah, I think that this effect, but basically creating given the how a city appears at night, making being able to making an image taken during daylight, transforming it into the night version of it. It's kind of another way of applying style transfer, like it has been done here. And it's incredible how it's not just style in terms of painting. It's just it's style in a bigger in a broader sense. And so it's kind of how to transform the content of an image given how the content in another picture is represented in some way. Exactly. And it's very, very, it's not just, as I said, a style in terms of painting, but it's a style in terms of representation in a broader sense.
Exactly. And what these people did was to understand how to extract the style, the style of a painting or from another image. How can we apply this style to another image? And this is really nice. And the idea is actually simple. It's not hard. And we can see it in the next slide. And when I first read the paper, it actually took me like several times before I was able to understand it, because the idea is not to train the network. When you start reading a paper now, it's always about a new training procedure, and it's mostly about a new training procedure, like a trick or something else. But here the idea is crazy. It's totally different. And that's why it took me sometimes to understand it. the idea is not to train the network. The idea is to train an input image. And you don't train the network at all. You use already a pre-trained network like VGG16, which is a deep neural network used for classification of ImageNet. The classification precision, I think it's like 94% or something like this. And you use already a pre-trained network like this one, and you don't train the network, you train the image. The goal is to find an image that resembles the style image you use, like Starry Night from Van Gogh, and in terms of style, obviously, but that also looks like the content image, the city in this case. And now let's take this image and let's try to understand how the procedure, how the training works. So the first step is to feed the image, the content image, the city in this case, to the network and get the output of each layer. You get the output of each layer and you save it. You put it apart. Here on the bottom, you see what is the output of each layer. You see, the more we move forward inside the network, and the more details we lose. Even though we don't lose much. At the last layer, yes, we lose a lot of pixels, but it still looks like the original one. And okay, so you feed the content image, you get the output of each layer, and you save it somewhere. Next, you feed the style image, Starry Night, to the network, and again, you take the output of each layer. And here the idea is how do we extract the style? How do we extract the artistic content of the image? And the idea is to extract correlations. And to extract correlations, what you do is you build a gram matrix that is basically the output of the layer transposed by itself, times itself. So you get a matrix, and this matrix is what you see on the top. So you see, the more we move forward in the network, and the more this gram matrix look like the style of the style image. This is because at the initial layer of the network, the style tries to understand the tiny details. And the more we go deeper in the network, and the more the gram matrix will look at the general details of the style. So this is the first step of this procedure. We feed the content image to the network, we get the output, that's on the bottom. Then we feed the style image to the network, we get the output, we multiply the output of each layer by itself transposed, and we get this gram matrix that is at the top here. Next. And this is what I just explained, so we can skip also to the slide after.
Okay, perfect.
Next step is to feed a random image. We want to train the image, as I said before. So here you feed a random image, a white noise image, to the network. And you repeat the same procedure I just told you. You get the output of each layer. And the idea is you want to compare the output of each layer with the outputs you computed before. So you feed the white noise image to the first layer, you get the output of the first layer, and you compare this output with the bottom images. Obviously, in the beginning, they will not look alike. And you apply some kind of loss function to to compare like the difference, and then you use the gradient to train the input image. You also use the output of each layer to compute what is the gram matrix for the input image, and you compare this gram matrix with the gram matrix you obtain for the style image. So you compare the gram matrix with the images we have at the top here. Next. And so basically, it's you do this at every layer. At every layer, you compare the output of the layer with the outputs you obtain for the original image and the style image, and you use a mean squared error loss usually. So you compute what is the mean squared error loss pixel-wise for each layer, and you compute the gradients with respect to the input, and you use this gradient to train what is the correct input image that minimizes this loss. And here you see on the right, we have the loss function, which is a sum of two losses. The first loss considers the style, and the second loss considers what is the content, how closely the input image looks like the original image. And I hope this is clear. If you have any question, just ask me, okay?
Of course, guys, I just, you can, of course, use the chat as usual. If you have questions, you can go back and, clarify better concepts. Don't hesitate to ask things through the chat.
Okay, so I hope this is clear. And in the next slide, we can see what is the overall training procedure. When you read the paper, I think this is one of the first thing you see. The slide before, I think.
Yeah.
And yeah, it looks complicated, but it's not. The idea is you first feed the style image, compute what is the gram matrix for each layer, and you feed the content image, the city, and you extract the output of each layer. And then you do training in the middle. In the middle, you feed this white noise image to the network, and at each layer, you compare what is the output with the outputs you obtain from the style image and the content image. And you do training, basically, according to this loss. Okay, so that's the main technical part. I will not go more into the details. I think that's enough. But if you want to ask anything, just tell me.
Of course, and let me also remind everyone that we do have our Discord server. If anyone wants to ask specific questions, of course, Alessio is there. We are all there, and so you can definitely use that. If you're interested in knowing additional details, don't hesitate to join us on the DIAMBRA Discord server, of course.
Yeah, exactly. And in the next slide, we see a really nice picture. Here we see a bridge mixed with the night cafe from Van Gogh. You get a painting that looks really, really nice to me. I wouldn't say it's made by a computer, to be honest. It's really, really nice.
Totally agree with you. These images, the capability they have to maintain, in some sense, the content intact is kind of amazing. Maybe before running these experiments with video games, I will share very, very high level details with you all about how I implemented it. I mean, mainly what are the things that you have to keep in mind when experimenting with these techniques. But if you do the things correctly, and you see the result is really amazing. Yeah, I totally agree with you.
Yeah, and in the next slide we see more examples. Here we see the San Francisco bridge mixed again with the nightclub from Van Gogh on the top. And on the bottom, we see Alice in Wonderland and Pablo Picasso.
Yeah.
You can do this. It's really easy to do. It's not like you need to be like a PhD student or whatever. You don't. It's really easy to start. You just need to find a good GitHub repo to start with. I give you some link at the end of the presentation. And you can play around and try a bunch of stuff. Try to produce your own paintings, and maybe you can even create something like very nice. Next, but Yeah, before I was talking about generative adversarial networks, and when I first heard about style transfer, I was thinking that the technique was about adversarial networks. In adversarial networks, you have two networks. One is the detective, and the other one is the generator. And the idea is you want to train the generator to train images, to create images that look like real images. And at the same time, you also train the detective or detector. And you try to train it in a way that it tries to understand if an image is fake or not. And this process is very complicated. It's like a zero-sum game where two agents try to compete with each other. And this is a really, really common technique to generate images now. It was discovered in 2014 by Goodfellow. He discovered also adversarial examples at the same time. And this is like the mainstream technique now to generate images. So when I read the paper the first time, I was like, okay, maybe they're gonna use generative adversarial networks to do style transfer, but actually no. The technique is different, as I just told you a few slides before. But we can use also generative adversarial networks to do the same thing. We can use a generator to generate an image that looks like other images. And from the next slide, in the next slide, we can see an example. Here we have an example where we have different input images, and we apply different styles to these images. And this particular training procedure is called the cycle GAN style transfer. And I think it was published maybe 1 year or 2 years ago. I don't remember exactly, but it's very, very new. We have another example in the next slide that is style GAN 2. And here, I don't know if you ever used, like, there are some applications now you can install on your phone that change you like from male to female, from female to male. They can change your hairstyle. They can change the color of your skin. And this is exactly what they do. There is a small generative adversarial networks in your phone that is doing all of this. It's crazy. And this is style GAN too. So another GAN here.
Very cool. You know, the capability of extracting, you know, in this case, again, style has a very broad sense, you know, meaning in terms of like your appearance, there's your hair, your gender, this kind of stuff. And is, you know, doing really a great job in these pictures. And yes, GANs are definitely something that is really a very mainstream application, you know, now a mainstream technique, let me say, for this kind of applications, and has been showing a great amount of power for these specific tasks.
Yeah, and I think GANs made a step forward, because with GANs, you are not restricted by just one style image. Here we see different style. We see Harry Potter first like a girl, then we see Harry Potter in like Indian Harry Potter or German Harry Potter, I don't know. You see there are different styles. We also see Merkel Harry Potter,
yes.
I think.
And also the other one on the bottom right is, I believe, is Bill Gates. So,
okay.
Yeah.
It's not German then. It's too small for me to see. So I didn't pay attention. It looked like a German guy.
Yeah, German is the one with Angela Merkel, you know, so there is also the German version.
But yeah, with GANs, you're not restricted to just one style. You can do different styles. And it's, I think, much faster than the neural style transfer, the original neural style transfer.
Yeah.
And yeah, finally, how can you start? Well, you can start with style transfer. The top link is a PyTorch implementation for neural style transfer. It's really nice. It's really easy to understand. I recommend it. If you want to play with GANs, you can instead give a look to the second link. This is an official TensorFlow repo where they implement style GAN. And here you can see pictures of fake people, people that are not real at all. And I don't believe it. It's crazy.
Yeah, there was, some, I believe it was like about 1.5 or 2 years ago, this kind of, images like these people does not exist. They were starting to appear all around, for example, LinkedIn or Instagram. And there were, examples of how powerful GANs are. And so, it's definitely a very cool technique and a very huge field, very, very interesting, of course. And the problem with machine learning is that basically every subfield is incredibly, amazing and really, it easily amuses people. And so the problem is, in order to go down into details about this stuff, you have to pick one. Let me say, pick one or two, let's say, because otherwise you cannot keep the pace. And so, it's great. It becomes, the problems with ML is becoming like, pick the one you like the most, otherwise you are gonna be behind it all the way down. Okay, so first of all, let me say thank you very much, Alessio. It was a great, very, very nice and interesting presentation. I'm really happy you had the chance to share it with us. And also, let me say, it gives me the opportunity to clarify a few technical details about what we are gonna see next now. So as you said, I'll try to be, because we are already 40 minutes live, so I would like to show you a few runs with the game, but I would like to share with you a few details. So first of all, you presented two different approaches. The first one is this, let me call the classic style transfer with deep learning. The second one is the one with GANs. What we are gonna see is based on the first one. Okay, so we are not going to use GANs, and so we are using the first approach. I should also say that VGG is the network I used, the pre-trained network that I used to carry out the training, for our own styler. And so basically what it works like that. I will input the image, the game image to the network, and the network will provide an output, the same content with the style applied on. So you will be seeing in this screen 23 different styles, changing during gameplay on the top part of the screen, and you will be seeing on the left the game as it is at its original version, and on the right, the styled game. Okay, so we are gonna use it in real time, meaning that I will use Dead or Alive, Street Fighter, Tekken, and Mortal Kombat, applying style of famous paintings there. Now, let me clarify a few things. So I will be using the first approach, and there are at least two important things that I would like to underline here. So the first one is I wanted to make it real time, and so I needed to use a small network to produce the styled image. And this is, of course, a limit with respect to a very good big network. So the output will not be as good as these ones, of course, because, in order to attain these results, you have to train a bigger network that works better. So this was one constraint on one side. So using a network that is able to provide real-time results. First, then I will run it during our streaming on the same PC. So I'm not sure we are gonna be able to use the game in real time. I will try it. In case it won't work, I also have recorded runs so that we can just take a look at them, but I just recorded them before our live.
Don't worry, it's gonna be great to see. I'm really excited.
It's really nice. Now, another important part is, as you can see here in the very top part, you have your loss is composed by two losses, the content loss and the style loss, and you have two factors, alpha and beta, and well, you have to decide if you want to make the content slightly more important than the style, or the other way around. So you have to weight these two losses, and how you set these parameters impacts how the results of your network. And so the particular point here is that first, not all games have the same resolution for date frame, and so different resolutions may behave differently. You will see Dead or Alive will have the bigger resolution, and that one is where the network works better, while other games are smaller frames. They have smaller frames, and so the result will be different. And so some styles, they will not appear as clearly as in other contexts. Then weighting the content with respect to style is also something that has to do with the image you propose. And so also, for example, if you're using cityscapes, all cityscapes in your dataset is one thing. If you're using something else, it's another stuff. Now, I trained my network using, I believe it was ImageNet. I'm not sure if it was ImageNet or Pascal, I don't remember which one. Anyway, I didn't train my network using frames from video games. And so, I trained the network on a strange, let me say, a general data set, and then I'm deploying it in the video games context. So,
but did you train it by yourself, or did you use a pre-trained network?
No, I used the pre-trained for VGG, but then I trained the network that will be producing the output here. And now it took about 2 days to train the network for all 23 different styles. So I do have 23 checkpoints for one per style, and I will be loading them in real time. So you will be seeing the image at the very center, demonstrating which style is being applied. Now, for some of them, it will be pretty clear which is the style that we are using, because the effect is so clear. Okay. For others, maybe it won't be so clear, but you can, see there things like shift in color palette, for example, or textures. So pay attention and keep an eye on these details, because for some of them, the weights between content and style, they are different. And so using the same combination for every style is also something that is pretty strange. For example, Van Gogh is a clear, every painting of Van Gogh, especially Starry Night, is something that is, it has very clear style applied on. But I wanted to use also strange things, and so paintings where there is not a clear style in them, but I wanted to see if the system was able to infer something about the painting and apply it on the game. So this is what I wanted to share. Let's try in real time. I'm totally not sure this is gonna work in real time, but don't worry, we do have the recorded session. So let's try right away. I will be using the game, so don't pay attention about don't worry about how bad I am at these games, because I am bad, and that's the reason why I decided to try RL on it. Let's start with Dead or Alive. Let's see if it is able to reach the real-time more or less speed. Otherwise, I will be just, you know, load different videos. Everything is loading up. We will start with American Gothic. So they will roll, and you will have also the caption text show, you know, explaining which one is the style applied. So let's see if it works. Oh, Alessio, I'm moving you on the upper part. Okay, so okay, so this is what. Okay, let me try also to okay, clear Discord so that. Okay, you see the idea here. So basically, the top part is the style, and you see the game on the left, and on the right, the result of applying that style to the game. Now, there are a few examples where, you know, for example, in this, you know, it's happening in real time now. Okay, now, so I selected, you see here, a few very, very famous paintings like this one. And so some things are, you know, this is happening in real time. As you can see, I'm playing. Now it's slightly slowed down, but still is working. Now this painting here is very, you know, particular because, you know, it's the painting related to where DIAMBRA name has born, because this is a duel between women. It's a very famous painting, and one of them is called DIAMBRA, so one of the two contenders there. So here we see Monet, for example. Now I'm playing also very well at the moment. Okay, nicely done. Well, you see here some, you know, texture has been applied, also shifting colors, of course. Remember, now this is a Kandinsky picture that is kind of a, you know, good effect here. In some sense, you can understand how colors translate from one place to the other. So from with respect
this
to
one is really good. Like
yeah, so some of them are working very well. You know, this one, for example, is strange because it's difficult because it has not like a specific peculiar style applied. More, you know, you are mainly transferring colors palette here, so a darker atmosphere with a very important red. This instead is working slightly better if you pay attention on, again, color palette, but also in some sense how brushes are applied with respect to the, you know, between painting and real time and the game frame. And so in some sense, yeah, you see here again Mona Lisa. This is one of the famous paintings, and you see is not super clear that we are applying Mona Lisa in this case. Now I also losing the rounds, but you know, some of them you see here, this one is applied very clearly because it's clear how edges are replaced by the frame and the, you know, the texture of this picture that we are using as style, source of style. Again, in this case, we are mainly applying the color palette. Some of them are just limited to that. Others have more, you know, sense in terms of let me call texture in general, style. Okay, this is Dali, also another one that is kind of peculiar in terms of how it is represented. We are always seeing how colors are transferred, and of course this is something that happens every time. For example, here we are seeing Picasso. Now this one is working not bad, let me say, in my opinion, since, you know, you can at least see those typical ways of applying, you know, styles to the picture. Now this one was a long shot using Pollock that you know, it's very, very strange, but still in some sense we are trying to replicate
it kind of worked.
I agreed with you. I agree with you. Now this is another classic in style transfer paper. You always find this Rain Princess as a style to be applied on images, and it's working more or less. Mainly again in terms of colors, not too much in terms of style. Then here Rembrandt. Let me say that you are able to see water drops in the very bottom part near feet. This kind of high contrast between water drops and the wave and the entire sea. While this one, the School of Athens and by Raphael, it's kind of again another long shot. It seems that it's again controlling colors, not too much style, but still cool stuff. Now here, dots, small dots, they seems to be applied on the frame as they are used in the very original picture. Let's see next, because there are a couple of them that are this one as again a very long shot. It's hard for me as a human to understand what's the style there. It's hard to recognize shapes. It's all a bunch of strange texture to me. I'm not an art critic, of course. Now this one is working very, very well, I think. It's kind of coloring everything, and it's transferring the mood that you find inside the drawing, the picture there, into our own game. This is kind of very, very expressive. As this one also, the Scream by Munch is also another one that is working not bad at all. And of course, in terms of let me say brushes as well as colors, they seems to be working for me. Then there will be the classic you see here, of course, Starry Night by Van Gogh, that is working again. And okay. And then again here texture is transferred very clearly again. And finally, I believe this one is the last one. So The Birth of Venus by Botticelli, and in some sense, again, you can see here that specific way of drawing waves that you find in the okay, yeah, that was the last style. In that regard, I was talking about how waves are drawn in Venus picture that are implemented also on the game. Now, since I'm not so good at playing these games, let me just load videos that are way more easy, way easier to discuss on. You see here the game I'm loading is Street Fighter now. Let me see if I'm able. Yeah, Street Fighter is loading up, and this is recorded again, but is also going, rolling in real time. And as I said, this game is as a smaller frame. You can understand that from the start, and so some of them, some effects, they will be very messy, meaning that you will lose resolution in them. You see some of these pictures showing, for example, this one, the Arnolfini portrait, is kind of, style from it is really hard to identify key things. Here instead, with the creation of Adam, you see we are losing a lot of detail in terms of characters like Ken and Yoon in this case. DIAMBRA again, here we are like desaturating everything, moving to shifting towards brown, dark brown colors. And so some of these pictures are working mainly in this regard. Here with Impression Sunrise, we are it seems that is applying texture, has the one that we have on the typical picture there. Here instead with the composition 7, number 7 by Kandinsky, colors, and as well as, let me say, a little bit of brush strokes. There are similar. You see here how Ken is drawn in this specific by this specific style. It's kind of, you know, it seems very nice. You see how it's the background that was green has been completely changed. Red is kept as it is, while we are using a different of course palette and also brush strokes. So kind of, you know, here we are darkening everything out with the use of this Lady with an Ermine and by Da Vinci again. And the next one you see is again something, you know, here is slightly more clear that we are applying that style, even is again is not super clear that is a Delacroix painting, but still it still makes sense. There is a similarity between the game and the picture. I cannot say the same for this specific case where you see here Mona Lisa applied on Street Fighter. That even just mentioning this is strange. You see here. Now, with respect to the previous example that we saw, I'm referring to Dead or Alive. Here, since the resolution is lower, the style is applied in a less efficient way. Let me say it's less clear as this one. You can hardly distinguish between characters with this style because it's just shifting everything down in dark colors. And so some of them they work for some resolution, and some others they work better for others. You see here Dali style again. I can also try to speed things up like this one. Okay, we have Picasso here, like Can drawn by Picasso. Not bad at all, let me say. And also the gameplay is not so bad. In this case is Pollock, that again is not completely, a waste. I mean, some sense texture can, be recognized in the gameplay screen. Now this one again is Rembrandt. Rembrandt is very nice. That picture, that painting is very good. Again here, strangely applied School of Athens, and now it's very difficult here to identify a specific style. While here, at least, we are able to recognize small dots as we saw in the painting, and so in some sense it's kind of meaningful. This one is again very strange, very complex, but it's just experiments. While here again, in my experience, this one, so the Great Wave, is working more or less in every game, because I'm not sure what's the reason, but it seems that it can be applied easily also on a smaller resolution. Also the Starry Night is working. You see an Hadouken drawn by Van Gogh. So it's kind of strange, and it was pretty clear there. So again here finally the Birth of Venus by Botticelli is we are inheriting here mainly waves, shapes, and all this kind of stuff. Now let me, I would like to share with you, at least briefly, also Tekken and as well as Mortal Kombat, because I tried them all, and it can be nice to watch them. Let me speed things up here. Okay. And so again, list is always the same, so 23 different styles changing in real time. And again, this frame is again a different resolution with respect to the other live, is smaller, and so it behaves differently with depending on the game you use. Resolution in input of the network is of course one of the factors that define at which level of details you are able to apply this stuff. And yeah, so one thing I would really love to watch about this style is like about the great wave, that I believe it should be around here somewhere, because at the end of the sequence we have the great wave, and then we also have Starry Night, that is again nice to watch, because it's, you know, there the style is clearly visible, and so in some sense it's easier to identify if this behaving in a good way or not. As you can see here, the great wave applied on Tekken is working, and then we're gonna have the Starry Night. Oh no, yeah, first the Scream by Mook, and then you see here, you'll see here the Starry Night by Van Gogh. So, you know, it has been fun implementing this stuff, and also the challenge of making it work in real time, or at least near real time. It was a great challenge, and also fun. You know, doing this stuff, you always learn a lot, because you have to face specific problems and you know, try to speed things up. Let me end this tour with Mortal Kombat, that, you know, it's always also fun to watch. Now, I don't remember exactly if this resolution was higher or with respect to the last we saw. Again, most of the time you will be seeing color transfer applied, and some others the very style applied to the image. And yeah, so, you know, using these approaches, you can definitely learn new things and also do cool experiments. I hardly think this kind of processing would help a reinforcement learning agent to better play, you know, the game, because
I don't know.
you know, I think this processing is just to have fun playing around with the stuff, but you know, it's at the same time it helps you also familiarize with models, with things like layers, how they are used, how losses are built, how to balance between losses. This is something that you have to be familiar with. For example, when just to give you you know, an example, when you have segmentation, also very easy binary segmentation between two classes, and you have a very unbalanced data set, meaning that you have, for example, one class that appears in you know, just small, just a few pixels, and the other one that is basically everywhere. Well, you have to play around with weights in your losses and manage this stuff to obtain results you need. And so, of course, it's a way to you know, to experiment around and also have fun. That always helps. Let me move apart from, you know, Picasso can be good, just to, you know, take a look at how Picasso is implemented in Mortal Kombat, and of course, you know, it's kind of fun watching how this translates, how Cyrax is transformed by the style of Picasso, and also I believe, okay, here, you know, Pollock is kind of Pollock on Mortal Kombat is mind-blowing in some sense. It's kind of really strange, a very hardcore result. And then I'm really curious to take a look at the Great Wave picture, and that is another one that is really cool. Let me try to move here. This is Rembrandt, and then after this one there should be the Great Wave.
It will be nice to see Guernica from Picasso, or some other painting from Picasso that is very with squares and segments and lines.
I totally agree with you. It's easy to, let me say, for every style you have to train, but you need, at least from the code that I worked on, you just need a couple of epochs. That is more than enough, because I started, I tested like training for 2, 3, or 10 epochs, and basically the result is more or less constant after the second epoch. So it's kind of not too lengthy, depending of course on the data set you use. And it's definitely doable, very easily doable. You see, this result is kind of cool. It's the Great Wave is able to capture edges in a very good way for Mortal Kombat. Is give that sense very clearly. And then let's see, because there is Munch here, and then the next one is gonna be, I believe, the Starry Night. So where in these paintings where the style is pretty evident and clear, it's easily recognizable what is happening in the game frame. So it's very nice. Again, here a Starry Night, and so definitely cool to take a look at. You see here a fatality under Van Gogh painting for Mortal Kombat. What about that? Strange things happening. Anyway, that is it, I think, because the last one is Venus of Botticelli, and that's it. Okay, so some of these pictures are really cool, in a different way of watching clear screens that are very famous, revisited, let me say, on different styles.
Yeah, I think we got the best results from those paintings that are not church-like, but they are more like environments. The night, the Starry Night.
I totally agree with you. In fact, we can definitely take a look at those paintings. I should have them here around. Let me see, graphic data, maybe here. No, just a sec. Style transfer. I believe it was one of these two models. Styles, You see, these are basically the images. So I totally agree with you that, for example, this with a very strange context, and those with environment like this one, or Munch, or Starry Night, they are working pretty well. Of course, it's hard to distill style from this image. It's totally complex, and of course,
if you have like a portrait, it's hard to extract a style, I think.
I totally agree with you. In addition, let me say that the other point here is that the fact that maybe you have to use different weights for different type of styles, and so you have to experiment a lot. Meaning, I've been using more or less just I believe 3 different sets of weights. So, for example, weight number, let me say set number 1, 2, and 3 for different styles, and so I was just choosing them, among these 3 different options, depending on the results they were providing, and then so maybe these 3 sets of the style, they were not enough to cover this diverse set of style images. So maybe they were working good for Van Gogh and maybe for Munch, but not for these portraits. Maybe for these portraits, different ways were needed in order to perfectly capture what is the style inside that. Okay, so guys, I believe that today we saw enough. First of all, let me say a big thank you to Alessio that was here going through the implementation detail, and so how neural style transfer works, covering both the classic way of doing that also GANs. So thank you, Alessio, again. It was really interesting to watch your presentation.
I hope it was clear.
yeah, it was definitely. And again, this gives me the opportunity to tell everyone, on our Discord server, everyone can join it and ask additional questions if interested in this stuff, in getting in touch and share nice resources. And yes, of course, so we are there, and if someone needs more explanations, don't hesitate to join us. Okay, so today is Thursday. Next week on Tuesday, we'll see if we will have more submission to tests for our AI tournament, and hopefully we are gonna also take a look at how the training is going for Tekken. I'm really curious to see if we will be able to land a good agent also in that game. And with it, I think today is it. Alessio, again, thank you very much. Hopefully we'll talk again soon. Everyone, thank you for watching. Thank you for being with us. I would love to see you in the coming episode, especially starting next week with our tournament, and of course a lot of great news soon on these screens. Thank you again. I wish you all a good night. Bye bye.
Good night.